Number 75, this is also about the fundamental theorem of calculus. So find the area. So first of all, what we're going to do is find the antiderivative of 2 over x squared plus 1. And then it's over the interval from 0 to 1. Now, when you have a constant like 2, you can factor that out. That way, it makes the integral look a little bit easier so that it's not as cluttered. And then, what function is it that you take the derivative and the answer would be 1 over x squared plus 1? You're right, that's tangent inverse. So the 2 will stay on the outside. The antiderivative is tangent inverse of x, and then that gets evaluated from 0 to 1. So this will be 2 times, and I could just leave that factored out. Then it's going to be tangent inverse of 1 minus tangent inverse of 0. So tangent inverse of 1, that is pi over 4. Tangent inverse of 0, that's 0. If you're not sure about those, you can, of course, go like this. What is tangent inverse of 1? And then divide that by pi, change it to a fraction, and it's 1/4 of pi. Also, tangent inverse of 0 is 0. So then when you reduce this, that's going to be pi over 2. Then I know of a good way to check and make sure that I got it right. Go ahead and graph this function. So 2 divided by parentheses x squared plus 1. I need to make sure that it includes 0 to 1. So 0 to 3, I'm just going to change it to 0 to 1. It looks like this. And then go to second calculate, number 7. And that will integrate for us, going from 0 to 1. And it says the answer is 1.571. which is the exact same thing as pi over 2. Good job, guys.